How do's all? Hope we're all doing well. Okay, so new project time. Finally finished. Oh, a little bit of sun there. Sorry, blinded you. So new project. We're going to be looking at upgrading, redoing, changing the current solar system that I created, which you can just see behind me, which I did probably about 2 years ago now. It's been okay. Primarily I really built it just to learn about solar systems and how they work, make sure that it would actually power a few things. It's been used primarily for sorting out electric bikes. We've had a couple of instances where the power's gone out, so it's been really useful for running some computers, some very small things basically. When I originally made the system, I say a mistake, but it's taught me that using a 12-volt system to run anything of substantial use. So say, for example, I would really love it to be able to run 2 fridges or 2 freezers, possibly a washing machine if I'm lucky. So the new plan is to go from a 12-volt system, which obviously has its inherent problems. You know, cables need to be quite thick due to the amperage that's pulled off of them. Also, the fact that when I built this, I originally did it with lead acid batteries. And of course, the biggest problem with those, apart from the fact that they don't actually last too long, I think you've averagely got around sort of 3 to 5 years, depending on how much you spend on the batteries. Trust me, I didn't spend that much on these ones for the original project. But it's the depth of charge. You know, lead acid will only let you pull down to 50%. So while the fact that there are 440 amp hours there, 220 of them are only usable. So yeah, with that in mind, the idea is to change the system, which I'll let you have a look at what we've currently got running, but is to replace it, get it up to 48 volts. It's probably going to be a Victron build with a few components that aren't, because at the moment what I'm doing is I'm sort of doing it bit by bit, because obviously Victron is amazing equipment. In my opinion, everybody else that I've seen using it has never had any problems with it. So I think I'm going to go with them, but it is expensive. So unfortunately, I need to sort of do it bit by bit as I get things. So today's project, or what this video is going to be me just swapping out the current connection to the very small little inverter that I've got, the 12-volt inverter, swapping it out to a proper consumer unit. But anyway, let's have a look at the system as is now. And then what we'll do afterwards, or possibly what I'll do is I'll cut to that actually, is like show you the current panels that are on the roof and stuff. Anyway, for now, as you can see, just standard lead acid batteries, nothing special. Ideally they're going to be one of the first things that I change. We're going to move up to lithium ion, which what we'll do is I'll also cut or splice in halfway through the little design that I'm working on, you know, the schematic of how it's actually going to be and stuff, so you can see that. Anyway, so from here, obviously we come up, we've got some quite heavy fuses here, 150 amp, to allow the inverter to pull what it needs when it needs, because this is a 2000 watt but peak surge of 4000. And it's done us so well. It will start most things. Obviously the draw on a 12-volt system is incredibly high, so as you can see, it's quite heavy gauge cable, at least going up to the inverter. Then we've got our solar charger. This great little machine, I've been very, very happy with this, and the best bit is in the next build, because this is a 12, 24, 36 and 48 volt charger, I don't need to change it. So that's great. I'm really, really happy about that. Then just above, we've got our PV combiner box, which is great. It just saves you a lot of grief. It's just so much easier to have it all independently fused. Obviously inside of there, you've got your standard, there's an RCA, and then individual trip switches as well. So that's going to be staying, so that's great. However, over here, you see this small little box that runs basically out of the inverter's 2 sockets and disappears up, and then along to some sockets and to another socket that goes into the tool shed, this is where I'm going to put the consumer unit. So basically what I'm going to do is start by putting the consumer unit in, because it means that I can terminate all of the sockets correctly, even though I'm not going to put load on them, because obviously the system couldn't handle, you know, running 2 freezers or a washing machine or anything like that. However, the good news is, as mentioned, because I need to do it bit by bit, it allows me to buy components. Yeah, I can start work basically. So that's going to be the plan for today. So without further ado, let's get cracking. Whoa, hold on there, Ben. First things first, we got to go through and show the plans that we promised to show. So as you can see in this first one, this is the grand overview that sort of breaks down the solar system itself, how the panels work, all the cabling that's required. So let's jump straight to the panels themselves. They're 24 volt, linked in series to give us up to our 48 volts. We're going to have 10 of them, so this will give us 3,300 watts in total. Next, let's move down to the bits that I'm keeping, which is going to be the solar charger itself and the PV box that brings all of the panels together. No need to change those, at least not now. I probably will in the future swap out the solar charger for a Victron unit. This is just purely so that everything can talk to each other, because I know that the Pylon Tech batteries like to be able to control the amperage that's being delivered to them. So that's something that I will probably look at later. Okay, next, speaking about the batteries and basically the Victron items, you can see that we have got ourselves a links distribution box, which basically allows us to fuse everything, which the batteries will be 125 amp, the solar charger 125 amp, and the main cable running to the inverter charger, the multi-plus, that's going to be a 200 amp, just so that it can deal with the absolute peak that the system can deliver. Next, speaking about the multi-plus 2, I decided to go for this one just because it has a continuous, I think it's continuous of 4,000 watts, which is more than I will ever need, and a peak, I think, of something like 9,000 at 60 seconds, which yet again, I won't fuse the new consumer unit to allow for that. I wouldn't want it to go that high, so basically the system would trip well before it got anywhere near the limits of the cable and the system itself. The brains of it is going to be a Serbo GX, I think that's how you pronounce it, with a GX50 display. Obviously get that all connected up to the internet. I'll probably run a direct cable from inside the house to the Serbo so that it can be all managed online, and so that I can do firmware updates and such. And last but not least, the consumer unit itself, which is what we're going to do today in this video, just so that everything is above board and as safe as it possibly can be. So with that said, and as I just said, let's get cracking. So back at it. For this video, as you can see, it's pretty much dismantling the previous system that I built back in the day. So here we are, we're just trying to make sure this box, I really wanted to try and make sure that this version, or version 2.0, is the best that I could possibly do. So everywhere I can, I'm trying to be as accurate as possible. So yeah, just swapping up and getting the consumer unit on the wall. know it's not ideal to be wiring in just a standard plug fitting, but it was just the easiest way with the current system to keep it running, to carry on charging batteries and such, before I swap it out for a real piece of cable. It'll probably end up being a standard 2-core plus earth, probably 16mm, so that it can handle all the way up to 40 amps, which will be the absolute max that the new inverter will push out at 240 volts. Actually, I think it's 37.5 amps, so we're within tolerance. Okay, so always the fun bit now, just wiring in the existing cabling. The reason this bit's always such fun is the higher you go up, just the toastier it gets. So it may not look like it, but I was absolutely sweating buckets doing that bit. Anyway, back down to the consumer unit. Let's get these cables did. So happy days, we are done and dusted. We now have a proper fuse box. Okay, yeah, admittedly the way in which this little cable that's plugging into the inverter isn't perfect, but oh, hello, we just got a mosquito just trying to munch me there. Yeah, this isn't perfect, but obviously I'm going to be swapping this out for another inverter. So this is just temporary, you know, this connection here. So not too worried about that. But happily now the two sockets, so the one that's in the tool shed and the one that is over just down there that actually powers the well pump, are all done and dusted. I do need to put another couple of junction boxes at the top because there's actually enough space here for 6. I'm waiting for some new fuses and RCAs because these are a little bit too high and I don't really want to be putting those on there. So yeah, all in all, not too bad. Hopefully you enjoyed, and I'll see you in the next one.